Hi there, everybody. I hope you're having as good time out there as we're all having inside the room here, getting ready for another wonderful show. Yuexiao Shen is going to be here today. He's going to be telling us about an observatory he's put together, and we're going to enjoy that. But before we go there, I want to do some things, get you ready for what else is happening around here. For one thing, next week we are going to have TAC shots, TAIC shots. The Astro Imaging Channel has invited everybody to send in pictures of their solar system shots over the last few months. And we've got them put together. And Arno has done a good job. He's put them to music and he's uploaded it and he's ready to go. And so I've seen a lot of the shots as they come in, and they're pretty impressive. So that'll be another one of those efforts. And those efforts are generally over here, and you can see our previous efforts of what we've done in the past. And they're pretty good collections of what people have done. We've got 12,500 subscribers, and some of them are really good astro imagers. Um, we don't have a workshop planned right now. We're still living off our past glories here, but you've got a lot of data here that you can go over and grab, download it to yourself, and process away and see how you do. And then you can come look up the different shows that we had where we showed them and see how your results compared with everybody else's results. Um, we want to be sure that you are active over here. Hi, Barbara. Hi, how are you doing? And Chris is here, and all sorts of people are starting to show up over here. This is a place for you to ask questions as we go along. You show will be answering the questions as from time to time. So please ask them. I asked everybody to keep their cameras on today so you can see their little faces over here. Um, these are some of the people that helped put on the Astro Imaging Channel, and I want to thank each and every one of them on this Easter Day, this holiday, for being here. And yeah, we have a good time before the show and stuff like that. We could use some more people helping us. Okay, so if you're interested in helping us, please hit the contact button over here. And this is where you can tell us that you're available for some help. We beg people to be presenters. If you're at all competent in astroimaging, you're probably smart enough to put on a program for us. So write us and tell us what you'd like to do, and we'll probably be able to find a spot for you. We want to remind everybody from the calendar that although we've got a lot of good things coming up for you here, Roland's going to come back and tell us about the update on Voyager. We were talking rather extensively about the state of imaging software before we started the show tonight. And then Brandon and then Jose is going to be here. And then we're going to take a day off. We have to take a day off because we're not going to be here. We're all going to be in airplanes and RVs and various other things going up to San Jose because San Jose is where the Advanced Imaging Conference takes place. And that's where some real advanced imagers are. And we get to go up there and um, just hang around with them and be in their presence and see what they've got to share with us. And then we've got some other things coming up, but you'll notice that we're kind of running out of programs down here. That's why we need you to come in and contact us. But that's not our issues today. Our issue today, I'm going to stop sharing, bring it back to the whole bunch of us. And it's a time to introduce Yuexiao. Now, Yuexiao is going to be having a little bit of his biography here, so I think it's about time to turn it over. And go ahead and take over, Yuexiao. Share your screen and tell us what you got to tell us.
Okay, thank you, Alex, for the introduction. So, okay, so can you see my slides?
We're seeing your slide, not the presentation part of it.
Okay,
Yeah, there we go.
okay,
Now we're going. Now we're perfect.
okay, okay. So, good evening or good morning to other part of the world. So, my name is Yuexiao Shen. So today I'm very excited to talk about our West Texas Observatory project. That's the project is done during the COVID pandemic, right? So before go through my project, I'm very excited. So I first introduce myself. So I'm an assistant professor at the Department of Civil Environmental Construction Engineering at the Texas Tech Universities. So usually I don't introduce this during my academic conference, but here I just introduce that my work is doing some wastewater and water treatment and some environmental and energy-based applications. So I have a background of chemical and environmental engineering, so that's my expertise. But I also enjoy my life. So you can see that this is a telescope I set up during my backyard when I moved to West Texas. So originally I came from Shanghai. I was born in Shanghai and then I moved to Beijing for my college. So I stayed there for 6 years, finished my master and undergrad and master program. That came to US. Right, the first station is Penn State. So I studied at Penn State for my PhD and one postdoc. I spent there for 6 years. Then I moved to Bay Area. That's a very crowded area, very expensive. I started my 2 year postdoc in the UC Berkeley. Then I came to West Texas. Actually, I spent some time in the East, some time in the West Coast. Now I'm actually in the like Southwest of the United States. So I enjoy photography. I like photography. That's why astrophotography is one part of the photography, right? Originally, I do landscape photography. So these are the photography I did when I was at Penn State. So I have enough time to go into see different stuff. Then I moved to West Coast. So there are different phenomena that I can see. And then this is the final photo is actually is the Oregon coast. So that's the called the songs songs well, right? So that's very amazing. So I like photography. So why I want to do the astrophotography. So one day, I mean, when I was at Penn State, I was amazed at the photo of Orion Nebula, but I don't know where can I start the astrophotography. Now I start to learn some websites. You see, Cloudy Nights, astrobiocell.com, and Astromat. I can say I love this website, but I also hate them because they will drag your money. Right? They will drag your money. So actually, I got my first mount, NEQ6, EQ6 from a Canadian fellow. I drive probably 2 or 3 half an hours and meet him around the border of the United States and Canada, and got my first refractor Vixen from a Maine fellow. So this beautiful scope now is in folks from West Virginia. We still contact on the cloudy nights, but I don't know where to start because nobody teach me. So to run this equipment is very heavy. So when I uh, moved to California, so once upon a time I went out with my friends because my friend is a mentor for me. So actually I set up everything in a very cold night and like hook up everything. And then, oh, finally I saw, oh, this is the first thing I imaged. That's the Orion Nebula. Yes. And I got my first images, right? I see it's very beautiful at that time. But now, according to my current standards, it's just the entry level. But at least I started the astrophotography image. So I systematically learned the astrophotography when I was at Berkeley for 2 years. So this is the CalStar party I attended for 2 years. This is the happened in the Lake San Antonio in California. So you can actually see that these have a couple of like imaging system. Our car is like just around it because we separated this from these visual guys. They hate us. Why? Because during the night we always have like a red light and we are very loud, right? So we are imaging people, but they usually go to sleep after midnight. So then we are just active the whole night. So, and our a couple of friends, we formed a small group we call the Hotpot Astronomy Association. Mostly are engineer and scientists in the Bay Area, HPAA. We actually get a hotpot that's from Chinese very famous like a meal. So and then all this flavor like all around this camping. So they're amazing. We attract many friends from different people. So I, for these 2 years, I systematically learned the astrophotography, and you can see that Bay Area. Actually, I stay here, UC Berkeley, but it's very heavily light polluted. So I drive almost 3 to 4 hours to these dark sides, and then sometimes I go with my friends. But later, when I learned everything, I just go by myself. Sometimes I get scared. I feel that we have mountain lions, but later I just get used to that. I imagine probably in the mountain and I drove back for another 5 hours. So it's really heavily travel. So when do I start to think about a remote setup? So I probably know how to do autofocus. I know the cable management, and then finally my mount is upgraded to Astrophysics 1100, and I also upgraded to a dedicated CCD camera like SBIG 8300 and then QHY 16200A, and I also upgraded to a premium refractor Takahashi TOA 130, and I got my first long focal length telescope RCA. So what actually motivated me to do that is I know that I cannot do LRGB imaging during my Lubbock new home backyard. It's still light polluted, especially there is a street light. I really want to shut it down with my laser, but at the end of the day, I didn't do that. So I have to travel 3 to 5 hours to a dark site. I'm just at the beginning of my career. I need to go to tenure track. So I don't have time to do it like every week, right? So I have to miss a lot of clear nights during the weekdays. And actually, our club range, it has a very dark environment. Actually, it's a 1.5 bottle, 1.5 class. So, and my club president is very supportive to like help me to build a remote observatory. So this is my current club. So it's in Lubbock, Southern Plain Astronomy Club. So everybody they are very friendly. So where to start? So I have no experience. So during the first year of the pandemic, I just want to build a pier during my backyard because I don't want to move my tripod back and forth. It's really heavy. It's a Lansmandy HD, the folded, it's still very heavy. So I meet a builder that he actually introduced his team to me. Then we are starting working on that. So we dig a bigger hole, we put a 12-inch solid tube, and then we pour concrete. You see these concrete trucks going to my back alley, and then after like a few days, there's a nice pier in my backyard. And my wife is not mad at me about this. And if I want to sell this house, probably I will break it, right? So that's the beginning. So I can do the imaging at home very easily. So, but then we come out twice, whether it's roll of roof or dome. I have to think about the cost and the control. So usually, if I just do a project by myself, I can choose a dome. But I check the price. Price is pretty high, and the control. I need to control the rotation and then the open the roof and then rotation. Right, there are two kind of control. Then maybe there are some problems. So I just think about that. How about the roll roof, right? So it's easy to control. I just need to open the roof and still the price is pretty high if I just do it by myself. But if I think about the team, the cost can shut down a lot. So I actually look at a lot of threads on the cloudy nights. So I'm inspired by a couple of folks, right? One is Chris from Florida, Chris Gomez. So he has a nice roll of roof observatory in his backyard. And then Paul and Chris White also, I contact them and they show their project progress. So I have to give them enough credit here. So actually, I also want to thank Terry here. So in our astronomy channel, actually, I contacted him a long time ago, and he showed his unique observatory that is totally remote. So for us, it's not totally. So I had to go there a couple of weeks, every few weeks. So actually, I got inspiration from these guys. So they're very helpful. So the summary is I actually find a dark side at my club ranch. Later, that is the land is totally purchased by our previous club president. So he's very supportive for me to build an observatory. And most importantly, it has electricity and internet. It's just 1 hour and a half away from my home. So if you look at the map, so this is Lubbock, this is Dallas, and then we are in the middle of nowhere. It's totally very dark. So it's like dark +2 near the horizon, but above, yeah, I mean, just above us, it's around I think it's around +1. So we also think about the weathers, right? So it's around like 60-90% sunny day over the year. And during the January, February, usually after cold front, it's pretty good. And now this time of the season is the worst of the season because it's very windy in the southern plain. But still after cold front, we can get pretty good images. In the summertime, we have thunderstorm and we have smoke. I hate smoke from California or somewhere, maybe Colorado regions. They always migrated to the east and our region is affected. So then the golden imaging time is from July to November. Usually we have very good. So it's pretty good. And then after the winter time, we need the cold front visit us. Then we can have very good sea. So and I know some builders who build a pier in my backyard. So I know some design. I can talk to them what I want. And I also contact about the our plan, right? Fortunately I get connected from Scott from Backyard Observatory twice. I also got a quote from Observatory Solutions. So finally, we decided to build in the second year after we think about this plan. So then let's look at where we started. So at the end of 2020, we start to build because uh, all of us, our team members, don't want to go to like a mobile, go outside to do the imaging. We just want to save time. So basically, this is what we did at that time. First, I get this project approved by my wife. You know, when doing astrophotography, you have to approve by wife because it's a ton of money, right? So if your wife supports, so it's good. So you have to be good to your wife, right? So then our team formed. We have four members. In addition to me, we have five people involved. So we got the BRO connected. So this is a very good thing. I don't know how to build this stuff. Uh, so some people ask me how to get it connected. I just will say to be patient. If they reply to you, just to pay the deposit right away because this is make sure that you get yourself on their list. And our landowner and we probably know when our hour will be constructed. So then you can see that from the construction date, it's around April, like around 5 months later. So what did I did during this 5 months? So I did a couple of things. We draft a site agreement with our landowners. I mean, this is not that important for us because we know very well. I know very well to our club president, but still, this is the official document to show that we used his land. So our foundation plan determined. I will explain this later because this is very important. I counted our builders. They still need to travel 1.5 hours to east to Lubbock. So, and they are very busy even after COVID pandemic. So it's very important to coordinate with them. And we ordered dense pier plate because we try to use the concrete pier, and they have a very long leading time after COVID. So it's also important to contact them early. And then we pour the concrete. We form these foundations with the help with these builders. And after we receive the plates, we don't want to use the template because there's always something off from the template. And then we cure the foundation for 1 month. So then that's actually what we do. So now this is the concrete the foundation plan. Looks like it's really amateur. It's not professional. Yes, I'm not in the construction major, so I just tell them that we need a concrete slab, and then we have four piers. The piers has a very huge foundation, and then below the ground, it's like 3 feet by 3 feet, and it should be separated from the slab. This is the most important thing. And you can see that I had the pier height is like almost 30 feet. So why I do that? Because I calculate a lot. So we choose a 10-inch concrete pier because I think it's stable. Because I use a 12-inch in my backyard, it's very good. It's cheap, and based on different dense pier plates, you can change the mount. So, but the shortage is its height is fixed. But that's fine. But we are not going to buy very expensive scope, right? We are not going to install very big scope. And something important is somebody will ask me, oh, how do you determine the pier height? So basically, we need a roof clearance. So whenever some emergency happens, we can close the roof. We don't hit our telescope. So our longest telescope, like refractor, is like Takahashi 130 or TAC 140. And based on the largest amount, we have AP 1100 and then Park 3 position. And the roof, the clearance is 84 inches. I asked from Scott. So we check that this height is good. And then we also make sure that the northern mount actually can see the Polaris because we want to use the Polymaster to get the polar alignment, right? You can also do other stuff, but we just be a little bit lazy. And the south mount can actually image pretty low targets. So finally, we decided 39 is our final, maybe 38. So this doesn't change too much. So this is actually what we did in the 5 months before the BYO team arrived. So yeah, then we start to dig holes. And you can see the hole is very big. You can always like bury one guy, right? And we have 4 holes, and then we establish everything. You can see I have the PVC tube, like this is like conduit. Actually, this is something wrong design. I will talk about later. So then we pour concrete. So this is the most important part. So if your builders is not familiar with this particular type of construction, they just think that they pour the foundation and then they continue to fill the solar tube and then they pour to the other side. Then all the concretes are get together. So I just stopped them. I said, please transfer some dirt on the top of the foundations. Actually, we transfer 6 inch, like a half a foot dirt on that. Then they start to pour the rest of the concrete onto the slab. So physically, so because they want to finish the job in one day, right? Not like if you do it in your backyard, they can come like every other day, but they are busy. They have to finish the job in one day. So this is something that we particularly do. So then after like we pour the concrete, you can see it quickly dried. You can see they have 4 piers, and at the same time we installed these dense pier plates. This conduit is something that I don't want to do. I later I did something else. So this is the final concrete after the curing for like around 30 days. So there are some thoughts about this if you really want to ask me. So first is pier foundations and the slab must be separated. So I asked the workers to put 6 inch dirt on top of the pier foundation and pour the slab. And this is because my workers has to finish the work in one day. If you do 2 days, that you can probably do separately. And I prefer to use 12-inch pier if I did it again, but 10 inches is more than enough. The conduit I mentioned is I use a too small conduit. I use half an inch, but the later all our cables is very thick. It's very difficult to insert these cables. So maybe 1 inch or 1.5-inch PVC is better. Okay, and then based on the requirement of BIO, there's no anchor bolts on the slab. So it's important to let your slab facing north, yeah, because you want your pier plates. So I use the compass to do it like back and forth, yeah, because there's no signal there. I cannot use my phone. I almost did it correct, okay, because I'm very OCD, so I want to be exactly facing north. So they also recommended me to put some rebars in the slab. Actually, we don't have a lot of rebars, so you can use fiber reinforced concrete. But at the end of the day, our project just using normal concrete. This should be fine. So this is something what we do before the BYO come. Okay, then BYO arrived. So they arrived and they started job instant right away. So one day they sent me a picture, and this is another day, and then after another day, you can see after 1 week everything is done. They are very efficient. Okay, they are very efficient. So this is the final observatory after 1 week. So it's very efficient. So I'm very appreciate their work. So their work is really highly appreciated in our communities. Yes, this is my wife come together, and we inspect the final our projects. And this is the video showing that I open the roof, right? I open the roof, make sure everything working smoothly, and then Scott just going to the another location to start his another project. Okay, so this is BIO finished the job. So BIO only finished in 1 week very quickly, but you need to prepare everything before them arrive. Okay, we choose concrete slab because it's in the middle of nowhere. We don't want these like mice, everything, small animals come in. So we think slab is the most stable platform. We don't want to use a deck version. So before the after construction of our observatory, we still need a couple of months before we let our observatory fully optional in fully functional. So what we did? We did a couple of things. So we paint our observatory. I use PPG because I don't want to advertise because my wife works in PPG company. I cannot use Sharon Williams. So, and I got a discount from PPG because my wife works there. And then we did the electricity wiring, so and internet and the sky roof system installations and cable management and cleaning. So for the paintings, yeah, this is the photo showing that actually I paint. And I asked a couple of friends coming here because I cannot do the job by myself. So you can see three guys. The left guy is like Master Lee from Dallas. The center guy is Master J from Austin. I'm from Lubbock. So three of us like come together like in the one weekend. We rent a trencher, and this is our club president. He actually is a retired professor from Texas Tech University. So this is the first time I work on this. Okay, so then we made a junction box of the electricities, and then we buried these PVC because we don't want our small animals bite these cables, right? And then we goes to our observatory, and finally we dig a hole, we insert this electricity into the system. So you can see I'm starting to work on this. It's very, very awkward because I'm not familiar with this. Okay, so this is some video showing that our story. I really appreciate these videos. So then we put internet. Internet is a little bit tricky because get the internet from the main house. You can see the PVC pipeline. It's very, very long, right? We trench it, we dig a long, deep groove, and then after we put the internet, my friend left, and I just filled everything. So it's like a 100 degrees Fahrenheit. It's very hot. So then I put the internet into the system. Then we have internet to get access internet to our observatory. So we instead installed so Master Lee actually he installed the sky roof system. So this is the sensor to control the limit of the open and the close, and this is the sky roof. It's pretty good. So the important thing about this, if in future people use it, if you already installed the sky roof system, so please use that to control the open and the close of your roof. Because if you use the hand controller, they are limited different. They might break this. Actually, we replaced this by twice. It's our fault. It's not the James fault. It's our fault. Then we did some cable management. I'm a person who really organized. So this is our shared PC who control the roof system. This is our power distribution. So I did like every week I go there, maybe once, maybe sometimes twice. So I have to drive every day. No, every twice a week. And I also made something to our peers. I pour some gravels and I put some foam so that I make sure that no insects coming out. And I also make some shelves or I can call scaffold so that every team members then can put their like computers and the power stuff on it. I think this is very useful. I also get this plug in and distributed from the power box. You see, I buried the cables. I think it's pretty good. So this is the final. We don't use the PVC pipe. We use this stuff to
Question for you.
You want to do that? I was just going to break in.
Go ahead, Eric.
Yeah, the one question is the question about putting dirt or mud around your pier. Is that just to prevent any physical connection between your floor and your pier?
Yes. So you can see we have dirt.
And I was wondering what kind of backup and control systems are you going to go over that? Like when does the roof open? When was the roof closed? Do you monitor humidity?
I will talk about it later. So they have sky roof system. I will talk about it later soon.
Okay. And do you have any power backup as well, or is it?
Yes, we have. So we'll talk about the details. Okay, I won't forget this. So this is something I did. Like every week, I have go there twice. I work only for 2 to 3 hours under like 105 degrees, very hot. Then I come back. It's totally exhausted. So this is the system. So if you want to look at it, so the red line is the internet. We have the main house. We get a cable. We have the router, and then we split it into switch through switch. We deliver to each pair because each pair need a cable, right? Cable. And then the green line is the share PC system. It controls the sky alert system. And also there's a power alert here, and then it also connects to the sky roof. And there's a sensor here. It also connected to the roof motor. So both these stuff, they connected to a UPS. So which means that if there's some emergency, we can steal the UPS to close everything. We just make sure it's close everything. Then I will go there because I'm the closest person to the internet. So there's another line. The orange line is the power line. So you get the power, and we deliver the power to the UPS. We deliver the power to each peer. So each peer has a individual power line and an individual internet line. So instead of this, later you see this magenta stuff. We installed a couple of like web camera then we can really monitor what's happened, right? If there's a mice inside, then we can look at. Actually, there's no mice. And then later we also have a outdoor camera. And then we have a all sky camera. All sky camera actually recently installed. It just installed last month. It's the final piece of the project. So, and then for each peer, right? Each peer, when there's an internet cable, we use a second switch to split them into two. One is going to the web power switch, so that you can control the power up and up, on and off. And you also split another one directly to the PC, so that the PC actually you want to control it remotely from anywhere of the board. And the power actually through this power switch, web power switch, you deliver the power to the equipment. That's basically what we do. So this is actually the final look of our observatory. You see we have 4 peers, and this is the shared PC system, right? Shared PC, and we have 4 peers. And you see there's a camera here. You can see what's going on. There's a second camera here. So this is on the other side of the observatory. You can see this is the motor of the roof. And this is another camera. You can see almost the four telescope at the same time. And yeah, so you can eat this shelf. This shelf is not looking good, okay? But I'm not a carpenter, but they do pretty good job, I think. I'm very proud of my work. So, and this is the outdoor camera. We can see what's going on, right? So we can see if there's a guy coming into. So sometimes our president coming here to do the mall, and then we see him, right? So, and our camera has a infrared system. So actually, they can see something totally without any light. But I gave access to all our team members so they can control in case that they want to see their camera. But we don't want it open when we do the imaging because this is still not good. So this is one camera from another angle showing that this is after sunset. The light, the star, the night is pretty clear. There's no clouds, but still there's still no all sky camera, right? So what do we do at the first couple of months is
You show.
Hmm?
Could I interrupt you and send you back to that last slide?
Yeah.
You said earlier that your roof, no matter what position these scopes are in, your roof will roll right over them, right?
Yes.
Okay. It's a little hard to tell from other perspective, but I think this is the best illustration of that. And that's something that is pretty important in a lot of ways.
Yeah. So before I do it, I go there, I measure. Okay. I put my telescope in all kinds of conditions. So I think this is maybe the best. So I check all our telescope. The longest is 140. So actually no interruption with this. Okay. So this is the website that we check because our regions here. You can know if they are. If this is live. So you know from the NOAA. But eventually we want to build a all sky camera. So my friends, they come up with together. So I'm not good at building this stuff. So this is the Raspberry Pi small computer. This is they use just PVC pipe. And then my club president really good. I really appreciate his help, Steve. So he made a bracket. It's very professional. Then we installed the computer inside. We installed the our stuff like outside. So then you can see, oh, this is the sky. But unfortunately, the camera we choose is not sensitive. We choose a ZWO or 120 MC. It's the lowest sensitivity of their like a planetary camera. In the future, I'm going to upgrade. But the other video is showing that during the early night, you can see some stars. right? This is the big deeper, right? They are going up. But if there are some very tiny cloud, you won't see it because it don't capture, and because it's so dark, you cannot get it. So eventually we will upgrade it, but it means that I need to put more work on it. So now talk about before operating, we need to do something. The first is the remote access. Remote access is not done by me, it's but just done by one of our team members, like a Master Lee from Dallas. So he did all the IP port forwarding, and then we can use Windows remote desktop. We can also use TeamViewer as a second backup plan to get access. So I'm not familiar with this, but basically it's very important. If you want me, you can contact me. I can forward the questions. And the second part is about the when you are closing the roof. So before we run the system, we need to make sure that everything is closed, right? So they have a ring sensor. So if we pour some water, the roof automatically closed. And if there's an internet shutdown, the roof automatically closed. If there's a power shutdown, there's a power alert, directly connect to the power line, not through the UPS, the roof will automatically close. If there's some USB connection problem, the roof will be automatically closed. And then we make sure that the UPS backup power can perform when complete the roof shutdown. It's actually done before we start to run the system. So yeah, this is the sky roof. It's not that matching the real sky, but actually it's pretty accurate. So we use this to control the roof. So everybody, it's installed on our shared camera, shared computer. So okay, so after this, we are starting to operate our system, right? Everybody is excited. So everybody will come here, install their system, and do the polar alignment. And sometimes I do polar alignment for them. So I'm the closest person to the observatory. So I just introduced my rig, okay? So I have a Astrophysics 1100 go-to mount, and my original scope is TOA Takahashi 130. And I use the reducer, and I use the QHY 16200A. It's still an old CCD camera, but I like CCD. So and I installed a motorized the flat panels, and I controlled it by feather touch focusers. And then later, I think I want to do some galaxies. So I actually want to install the RC8. But I sold my steel version. Actually, this carbon one is I borrowed from my friend Craig here. So he's very generous to let me use it like for free. So because I really like the long focal length, so I installed the moonlight focuser, and I have my own controller developed by our friends, and then we installed some other system. But the major things is controlled by the Pegasus Ultimate Power Box. It actually can control the two rigs at the same time. And then on that long focal length, I still use the old SBIG 8300. It's an older camera, and all the filters pretty good. Oh, they are expensive. Okay, they're expensive. So, and I also use a flat panel, but here it doesn't have a flat one, so I have to do flat manually. So this is my scope, or this is my two scope. Okay. So I want to do something in the future. Okay, so I mostly do LRGB imaging or HR for LRGB. So I spend almost 20 to 30 hours per target and 2 to 3 targets per month. Because CCD efficiency is low, and sometimes seeing is not being true for RGB image. I think in our channels, a lot of folks talk about different software. I'm still an older guy. I still use the Sequence Genus Pro. If it works, I probably don't want to change it. But now I know people want to choose Nina or Voyager. So because we set up a sky alert, our mount actually link to that safety document. The mount can be automatically parked if there's something wrong. So actually, our mount first will park, then the roof is closed. They are around 2 minutes before the roof is closed. So actually, we set this up. For astrophysics, I installed the APCC, but I haven't used it. Right, I'm lazy. So I also aligned the two scope. You see, I have ADM TGAD tandem guiding system. Actually, I aligned the two scope, but I haven't do the dual system at the same time. So I will learn Nina and the Voyager later. Okay, I just learn things a little bit. So in the future, I might think about upgrading my RC to a CDK10. Everybody think about a CDK. I still like RC. So So I will test it, and I have because my peer actually shared one of my partners. Actually, they can reduce my cost. All other three peers, they are only just one person. So 2 person actually own my peer. So we share the data. So we actually have Epsilon 160 from Takahashi. But the correlation is horrible. So I need to, I send it back to Houston, so let them check. So I also want to install like a wide angle. So I have it, but I haven't put it on time. So maybe I will install a rotator, better flat panels. So this is something in the future, but everything works very smoothly. So I can do long focal length and a wide angle, whatever we want. So everything's stable. I don't want to change. So this is my philosophy. So now look at some of my images, right? So this is the 2-panel like from Orion, Orion region. This is like M78. This is LDN 162012, right? So I imaged because we can. It's a 100 hours project from last October to this February. So it's almost like a half a year project. So 100 hours project. I cannot imagine if I can do like just go there and then take my rig out and then imaging. I have to do it remotely. And because we can do this, so this is the comics Leonard that we try to image in last year, like December. Yes, it's the first time I get the comic. It's very beautiful. And then it's just in the same frame of M3 clusters, right? Clusters. Also like galaxies. So you can see I image a variety of galaxies with my RC8. Once I say it's very, as long as it's collimated, it's very, very good. So I think it's the most cost effective. And I just think about the seeing, right? My seeing sometimes not very good, sometimes it's good. So I don't want to waste the money on a very, very big scope. Yeah, I'm still on my mortgage, so I need to save the money. So this is the galaxy, like the clusters. So the Perseus clusters, Abel 426. So my friends really like these. So of course, this is on my target as well. So this is some of my images I post on Flickr. I can share these images, I post these links. Yeah, and you can see some of my friends, the images, and they got ITOD and the promotions every day. You can see a lot of images. So they get very, very high quality images. So one of our team member, I think he presented probably last month, Ijo from San Diego. He got the APOD. That APOD is from our observatory. Okay, our West Texas observatory. So I'm very proud of him. Okay, very proud of him. So then talking about the images, so we think about what should we do to make the remote observatory very smooth, no problem. So we need to do a couple of things. So I go there every month. So I hope I can go there every 2 months. I don't want to drive. Okay, this road I drive probably. Actually, I spend one set of tire on it. I don't want to drive it there anymore. So every time I go there, I will spray pesticide. I will spray weed. I will spray grass killers to make sure that our observatory can run as long as possible. I will do the vacuum, clean the floor. There will be a ton of dust. Clean the spider webs. I might tight some rings because doing the remote operation, the temperature drop and increase because of the mechanics of these metal rings. They might be loosened sometimes. So I need to tighten. Especially my team members want me tighten. Yeah, this doesn't happen. Even the screwed one is the best currently, but maybe the bolted one is the best. So we need to tighten the rings. And I need to charge the outdoor camera. Sometimes I do the flats for my RC8 because RC8 collects ton of dust. I don't use any like a flattener, so all the dust directly go to my sensor. So if we don't do the cleaning, what will happen? So I show some images. So some bugs actually they have they have eggs in one of the telescopes. See, it's really weird, right? So you really need motorize the cover, okay? Motorize the cover. So actually, there are 3 times my team members and I have to let me go there really for the emergency. So the first is the internet temporary shutdown because there are some thunderstorm and then the total internet shutdown. We cannot get access to our remote observatory. So actually, we find out that the problem is on the router. If the router is good, our original router is not very good. So we change it to a new router So then everything will come back to the connection. So this is problem solved. And then the other problem about the virus attack, it's not COVID, okay? It's a real computer virus attack on the PC. So because some member and in our teams actually connect to the some program, download something and which is not good, then totally ruin our system. So I have to go there during that weekend to reinstall everything on the shared computer because our computer is get connected. So this tells you that if you do this remotely, you need to make sure that don't install anything not like related to our Astro programs, and ask my team member to be careful. The third thing is not controllable, okay? Because the ring sensor on the sky roof, there's a on the ring sensor. And then that's just doing the imaging, okay? You see there's some spikes to prevent the birds on it, but who knows, right? So when the poop is on that, it shows it has moisture. Then during the time we are imaging, the roof just automatically closes. But we still see the weather forecast is really, really good. This is no solution. If this happened, I have to go there again. So there's something about it. Okay, you can see that I sometimes do some cleaning. I'm not good at this, but I try to learn this to do some mowing. This is probably something I have to do in the summertime. So finally, I want to summarize the talk a little bit if you are interested in this. So you want to build an observatory, you want to know the cost. So the pier foundation slabs, the total is 6K around 2020. Okay, 2021. So the 4K is labor because the workers travel from Lubbock to my observatory. Each travel is like 4 hours. Okay, back and forth 4 hours. So, but the project is done in 2 to 3 days, and we cure for 1 month. But the totally material cost is probably only 2K. If you can build it by yourself, then you can save around 4K labors. The observatory is like 16 and 16. So originally the price on the observatory backyard of observatory is 8K, but the lumber price increased significantly during the past few years. Finally, our bill is 14K. Okay, so if you can build it by yourself, you can totally reduce the cost. Okay, and then after that, we installed a lot of systems, and then that actually cost our like 4K for the other supplies. So eventually, we have 4 people, 4 peers. So if we divide by that, each peer actually costs 6K. So it's still very, very cheap compared if you go to a commercial observatory because the reason why, because the maintenance cost is only $50 per month because we only pay the utility fees like a utility and internet and electricity, and I sometimes cover my gas and meal when I go there to do the maintenance. So the maintenance is really, really low. So you think about it, if you go to run a commercial observatory, that price pretty high per month, right? So our cost is pretty low. After 1 year, I think we already achieved that level. So if you really want to build your own remote observatory, so have a couple of things to think about. The first is determine you want to build one. If you want to build one, go for it. And then find a team that will save you a lot of cost. And a dark side with good weather is very important, especially with internet and electricity. If you have a good dark side, you can get access to electricity. And because we have a dark side, and I don't need to do these like a tax and other fees. So I think this is really, really good. I really appreciate our Steve to give us the accommodation for our remote observatory. The construction, you need to plan the well. So you need to get everything ready, right? Like the pier adapter need to be ready when you pour the concrete. And the concrete slab need to be cured for enough time when the BRO arrived. So everything need to be coordinated together. And the post-construction, the testing is very important. You need to make sure that there's no blocking, and then everything emergency happened, the roof can close automatically because, yeah, it's maintained by me like every month, but eventually when it's doing the operation, nobody's there, right? So finally, the maintenance is very important. You don't want the spiders in your telescope, right? So you want to dust as less as possible. So you want to clean the grass around, and then that's why I go there every month, maybe every 2 months. I just think about I balance my life. So during the weekend, I don't want to do anything with work. I just go there. So finally, I do some acknowledgement about my talk. I do thank my wife Wenji because without her support, this won't get it right. You need to get proof, right? Because I paid the 6K on this, and I need to thank our team members, all these members, Wei, Jianjun, and Yizhou, and Joe, and we work together. We together, so that actually reduce our cost, and we share a lot of like informations. Particularly think about Steve Mass. So actually, he wanted me to put information here. So if you are close to West Texas and you want to build your own remote observatory, you can contact him, and he can discuss with you, and you can build your own observatory there. And then, but the building is cost by you, not by him or me. Okay, and then later you just pay the utility fees. So I think this is very good. Okay, I want to thank Craig Patterson, who is also from Lubbock. He borrowed me the RC8. He also did all the electricity stuff. So I really appreciate him for the help. I also thank the robot and his team, Roberto and his team from the builder Dynamic Homes from Lubbock. They did an excellent job in the slab. And Scott from Backyard Observatory. Yeah, it's very fortunate for me and get him invited here, and then his team built a nice observatory for us. So I think it's very difficult to get him contact, but as long as you can get him contact, it's very efficient. Okay, I just thank Jim Collins for his Sky Alert system. Without that system, our observatory won't be functional. I want to thank Dan for his Dan Pierce plate. It's very high quality. And Darin from Takahashi America because he called with my TOA 160. I spent 1 year to dial the collimation, the tilted or something back focus, but eventually the scope is out of collimation, so I sent the scope back, and he did a wonderful job. So thanks for your attention. So if you have any questions, you can send me an email or you can post any question in the YouTube, and then I'm happy to answer the questions. Okay.
Great. Hey, Eric, how we doing on questions over there?
I don't see any questions, but let me ask. You can close your presentation.
Yeah.
Okay.
Stop sharing.
Stop sharing. There you go. What kind of seeing conditions do you generally get out there?
These are good questions. So my mount my mount can usually, when the scene is good, I can go to 0.3 arc seconds RMS, and then and then there's a 10 micron. The 10 micron mount is by Yizhou. He actually usually get much lower, so because use the encoders, right? So he can get like 0.1, 0.2. So this is the best seeing that we can get.
Well,
so
probably,
usually,
I mean, probably you're not getting 0.1 or 0.4 arc seconds seeing. I'm just guessing
that's
somewhere.
that's the guiding, okay?
Yes, the guiding, right? That's
guiding area. So I think it still cannot satisfy my RC8, but I think it's pretty good. So maybe I don't know what kind of scene, because you might have a scene monitor. So at least I can go to that guiding error is like 0.3, 0.3, 0.2. I can go to 0.2 for my astrophysics. I don't have an encoder.
So with the 16200, what's your arc seconds per pixel?
1.7, 1.7. 1.7 arc per pixel because I use a reducer.
Oh, so that's fairly large arc seconds per pixel.
Yeah, but my RC8 is only 0.7, 0.69 arc seconds per pixel. So I need a guiding error to below 0.4, so I can get very sharp images.
Mm-hmm. And how many images have you generated since you've been up and running?
Mine is every month 2 images because I only do LRGB. I don't do narrowband. So, but based on my team members, they usually can get 3 to 4 images per month.
You say you don't do narrowband. That's you just don't have the filters yet, or you just?
I have, but I just don't like false color.
Well, you're talking to someone that loves narrowband, so.
Yeah,
I-
yeah. So yeah, so I do narrowband imaging during my backyard, but then when I do a couple of narrowband imaging, I find the color tune is almost the same because they are blue, they are yellow, they are Hubble, right? And then you can also mix in a different style, but yeah, because CCD the narrowband is very very like low efficient. That's why I just go to RGB.
There's a question from YouTube from Chris Pagan. We didn't see any insulation in the shed. How hot does it get in there?
Yeah, that's a good question. So if in the summer, if it's 105 degrees outside and inside it's around 95 degrees.
So
Because
do you
there
open your roof in a couple hours or an hour or so before you start imaging?
Yes,
Equilibrate?
yes, we open the roof at least 1 hour before the imaging. And
I don't-
then, because it's a hour structure, so it will equilibrate. And actually, I find that in the summertime, sometimes we find the seeing at the beginning of the first hour is very, very bad because I think about the equilibrium. So after 1 hour, so then the seeing looks good because yeah, we need to open that probably 1 hour before the imaging.
You know, it's pretty common that the seeing early in the evening is not as good as a little bit later. I mean, we experience the same thing out the SRO.
In California, it gets very cool at night, even if it was warm during the day, quite often. Does Texas have a big differential? Does your part of Texas have a big differential between day and night?
Yes, for us it's quite different. So we are not southern Texas. It's northern, a little bit northern Texas. It's very dry. So you can get around 50 degrees, 50 to 60 degrees in the morning, but then starting the imaging can be like 90 degrees. This is for summer, but for the winter, it's also a drop quickly. So we need to focus all the time.
Well, that was my next question. So how often do you, I assume you focus between filters. How often do you focus otherwise?
I focus every 2 degrees, but I also did temperature compensations. So during the 2 degrees, they can automatically move because I measure maybe I measure 10-degree difference. I know the scope. So you can see my Takahashi, actually, they need to be refocused a lot because it's
yes, they do.
yeah. So, but when you go for RCA, because the carbon structure, carbon, so actually every 5 degrees, it seldom moves. But I'm a little bit OCD. I still focus, right? So you just want to get
No, that's good practice. No one should really be critical of that. Now, do you ever run 2 scopes at one time and 2 cameras at one time?
Yes. So I use the ultimate. So I control the several electricity line, and then I open the one camera. I shut it down because then I can open another camera. So I do just the one by one. I didn't combine them.
On your, I think you covered this, but could you review again the opening and closing hardware? What mechanics do you use for that?
Oh, what the opening? Do you mean the telescope or?
Yeah, no, the
Opening the roof.
the roof opening.
The roof
mechanism.
is from Sky Alert system from Jim Collins. Jim is actually also in California. So actually they can connect it to the roof motor and do some electricity or something. And then it's also ESCOM based, I think. So you can control it. It can connect it to all the software, and they can provide it a safety document. And if your computer can read that safety document, if it's unsafe, your mount will park first, and then your roof will close.
So do you ever find yourself, when there's nothing good to watch on TV or in the computer, that you're watching your telescope remotely to see it operate? Don't answer no, because we know the answer is yes.
Yeah, sometimes I look like during the night. I want to see what happened. So Especially sometimes I open the infrared camera to see what's happening. Sometimes, actually, I look at my telescope a lot because I want to see if the seeing is good. Because when seeing is not good, I go to RGB. When seeing is good, I shoot air. So
You show
So
I
the,
have, there's a couple of questions. One on the from the internet. And who was that? Asked Hema asked, do you have any future upgrades to the observatory in mind?
what do you mean? You mean observatory or the equipment? Observatory.
Of the observatory. Well, I don't know exactly what Hema's got in mind,
Any of it,
but
probably.
any. We like
Okay,
you guys
okay.
have used
Okay.
it for a year or something now.
Observatory is almost done. So last month we installed all sky camera. So the current observatory we almost done. Unless we are going to improve the all sky camera because our camera is not sensitive. But there's nothing that I want to do. Maybe I want to put some installation system inside, but I don't think it's a must because we already almost run 1 year. So, and the dust, I just go there every month. I don't want to put other cushions around the roof. Anyway, they will get dust, right?
So there hasn't been
Yuexiao,
any
can I
obvious.
ask a few things?
Just a second. There hasn't been any obvious things that said, "Oh, we did that wrong. We need to fix it."
Yeah, we probably already did everything correct. So there's nothing we need to
Okay.
improve it. And if
Take
we
it.
think about my system, I already introduced in my slides. Maybe I want to get an even faster Newtonian if I get it column, and then maybe I can get a CDK 10 because I think 10-inch probably the best I can get. I can still think I can get more details from a little bit larger, but if I go to 14 and even larger, maybe my wife doesn't allow it. Maybe, maybe it's too big for me. So my partners on my peer, he probably wants to get a six. Then maybe I will support him when he.
Okay. Thanks, Terry. You want to take it?
Yes, I've got a few observations, if it's okay.
Mhm.
When you first start building your building, if you want to determine north and south, you can take advantage of the winter and summer solstice to establish an east-west line. That's how I did it where we were, because there's a lot of, we didn't have a telescope out there to do with proper pole alignment. We don't have a pole star in the southern hemisphere. So we wanted to do this properly. We'd have to get a telescope up and do it properly, but you can take advantage of that. Put stakes in the ground in advance of building. Another thing you may consider are ground loops. I noticed that you have very long cable runs. You probably want to use a non-conductive media for that. There's ground potential and induction. That can be an issue and that can blow up equipment. That's something
Yeah.
you might want to look at because I have lost one computer and I don't have any long runs.
Okay.
Speaking of computers, imaging a computer is a very good thing in case you get hosed like yours, where you can just lay down your image with all of your settings that you spent so long getting correct. Because if I lost my computer and started from scratch, well, I'm not looking forward to that. But having an image, I just roll back up, lay the image down, and I'm up and running the next night. And another, with the all sky camera, I used to have a 120 ASA. Yeah, get another one. It'll serve you well. I went to a 224. That does quite well. I've only got about a couple of dead pixels. My 120 wasn't sensitive enough.
Yes.
Yeah, and
We're
APCC, since you're running remote, you can actually set up limits in that. So in the event that it stops communicating, it will stop at zenith, or it'll stop before it crashes into the ground. That's an excellent safety feature to have for remote installation. And my final thing, sorry for the long list, heaters. They're good to have running 24/7 just to keep the dew off the optics.
You mean the dew heater?
Yeah, dew straps. Yeah, I've got dew
Yeah,
straps
so
on mine running on the mirror 24/7 just to keep the dew from forming on
yeah,
the
but
mirrors.
we quite dry here because we are not southern Texas, so quite dry. But we get pretty dew, like not dew, actually frost in the winter. So yeah, we will keep it. So we will look at the humidity when it's really bad. So I will ask my team members to turn the dew on,
Yeah,
or if they can do automatic dew. So
Yeah, rock up and if you have a couple of days of rain and look inside your telescope, see if your mirror's got a bit of fog on it. If it does, you just whack a dew strip on the bum end of it and just keep it just a little bit above the ambient temperature. It's all you need.
Yeah, but we haven't rained for 2 or 3 months.
Oh, you're lucky then.
Yeah,
That-
we don't
yeah,
have rain, so
and,
it's not good. Maybe not good
oh,
for fire
oh,
control, right?
and,
If it really make
and,
fire, then everything will get burned.
and I got one more thing about comms.
Mm.
My comms are all done through a mobile phone network. There's nothing out there. And I use an industrial modem that has a series of relays on them. And this
Mm.
allows me to cycle power on and off with a text message. So in the event that you sounds like you have a central switch or router, and if that goes a bit funky, you have no way of resetting that. You can send a text message to your modem, and you can
Mhm.
set a relay to power it remotely. So
Okay.
might be something else to consider.
Okay. Got it.
Okay, so that's all I have. Sorry about all that. So,
Yeah, thank you.
yeah,
Hey,
it's all good from remote stuff. So these are little things that do crop up.
I got a couple of questions. What provisions do you have for taking flats, darks, and stuff like that?
I have CCD, so I can take a darks there, right? Because it has a mechanical shutter. Flats, for my Takahashi refractor, I already take it. It has a flat.
You go out there and take the flats and
No.
just set something
It
up?
has a panel. It has a panel there. It has a
Okay.
it has a light. So the panel has some LED light there, so it can get it.
Okay, so you've set up something on the wall or something that you can
No.
aim it?
It just on the
It's a-
cover. It's just on the
Okay,
cover.
it's a flip flat like
Yeah.
thing? Okay.
Yeah.
Uh,
But
The other thing I think it's real important when you get into something like this, I know that you love your three friends that just all got together and built this wonderful thing. What happens if somebody gets transferred to Orleans or Minnesota and now there's only three of you? Well, or, who owns this thing,
so we own the buildings. We own the observatory.
including all that concrete that's 4 feet
Yes.
underground?
Yes.
Yeah, and it's going to stay there after you leave it, right?
Yes.
Yeah. So, I mean, seriously, what does one do when you've got a group of four guys that says, "Hey, let's build a clubhouse," and then the club breaks up? What are you going to do? Or,
What did they say? The club?
well, the group. You've got this arrangement
Mhm.
and you've got $25,000, right? Just in the building, right?
Mhm.
That's a lot of money. What happens if
Yes.
somebody else wants to come along? What happens if somebody wants to leave? Can he sell his share? Can he, what happens?
Yeah. So basically, we have some agreement. For example, if someone don't want to quit the position the hobbies, and he can transfer his part peer to another peer if he wants to join the team. But then we also want to inform our landowners. So we will change the agreement because originally we have 5 people on that agreement. Then he will be quit. Another guy will come. Okay.
So is this something you guys change as you need, or is it
Yeah.
written? It's a charter. It's a
Yeah. So basically, if you want to quit, then basically he can sell his peer to another friend, something like that. But basically, currently, all of our team members wants to do imaging at least for 5 years. So we
we'll see what
haven't-
happens when it happens, huh?
Yeah. So I think after you got so many images, I think everything is paid back.
Yeah.
Right.
Okay.
So you got a 5 year, you can get at least like around 150.
You guys own the building, but you're on a lease for the land.
Yeah, so it's not a very official lease, but at least in agreement we said it's for 5 years. Right.
Okay.
So we can use the land for 5 years, and the good thing is, so our club president, like Steve, he will go there to stay there, like totally. He will get a house there, and he has a very, very good telescope he wants to run after his retirement. So basically, we can make sure that we can run at least for 5 years. Yeah, after 5 years, we can extend, and then maybe after another 5 years, we'll think about what to do. That's too long.
Thanks.
Yeah, you're welcome.
Have you thought
Linda-
about installing a seeing monitor? Because if the seeing is really poor, it may not even be worth opening the roof or taking any images. And you can kind of judge what to shoot based on what your seeing is.
Okay. And then all our team members wanted me to install that. And I hate that. So yeah, I think about it. I think about it because yes, I got it.
It really informs
Mhm.
what you're doing for that particular night. Otherwise, it might seem confusing, like the sky is clear
Mhm.
and it should be good, but your data's not good. What went wrong? But your seeing monitor will tell you a lot.
Yeah. So basically, I can forecast maybe 60 to 80% correct based on the weather forecast. If I live there for like 1 or 2 years, I know when the cold front coming, and after 1 day, it will be pretty good seeing. But then during the cold front, yeah, no, it's very poor, very poor.
Linda Thomas Fowler wanted to know how how long it took for you when you talked to BYO, how long it took for them to get back to you.
Okay, I get fortunate. It's just 1 month. 1 month, and after 1 month, so I tell my team members, and we pay the deposit right away. Right.
And I have a question about your roof opening east-west. Another presentation I saw where they opened their roof east-west. The question came up about after rain, when you open the roof, that rain can, like if the roof is wet or wet from dew, that's pretty easy for that moisture to just trickle down into the observatory. Do you guys have like a gutter or something up there?
No,
Or has that not been an issue?
Our place is pretty dry, and well, we don't have a gutter, so we never have this problem because, yeah, I haven't thought of that.
Okay, you may have some other questions out there for Yuexiao, and go ahead and ask them. Meanwhile, Tarek has asked us a couple of questions over there about first off using a dew heater with with an RC, and then taking flats with an RC. It's rather unusual to have real problems with dew on um, an RC because the mirrors are buried deep within the structure of the scope, particularly if you've got a shroud around it.
Yeah.
And so that's not generally too much of a problem. And as far as taking flats, there really isn't anything difficult about taking flats. Just point it to a blank spot in the sky. Use your t-shirts, flip flat, or any of the kind of standard things. They're the fact that it's an RC doesn't make it any much different than anything else, as far as I know. At any rate, that's what I know. So there. Have there been any other questions for you? Don't come in as we've been talking.
I haven't seen any.
Okay, then it's probably time to get ready to wrap it up. Okay. Want to thank you for being here today. I want to remind you that we all enjoy programs that are based on people doing things to make their astro imaging better. And I'm sure a lot of you guys have done some of that stuff. Some of you people, some of the ladies out there, you've all done some stuff that has made your astro imaging better. Please share them with your fellows here on the Astro Imaging channel. All you got to do is tell us you need to do something, work up a program for it, polish up your PowerPoint skills, and we'll get something together for you. And we would like to see you. We would like to see you do some of that stuff. Okay. Next week we've got our own crew. Tim and Eric are going to come in, and they're going to tell you about. Tim's going to tell you about how to do the image processing a number of images the same way in PixInsight. And Eric's going to talk about. Eric, what are you going to talk about?
High pass filtering to bring out the
High pass
details.
filtering. Yeah, image containers and high pass filtering. And we're also going to have TAIC shots. So please come on back for next week and enjoy it. And I'll see you next week. Okay, Molly, you're in charge. Take us out.
All right, let me look around my cat to find the end stream button. Oh, there we go. Okay.